Hey there, HMSers. My name is Josh Willis, and I'm with the Corps of Engineers Fort Worth District. In this video, we're going to cover the Terrain Reconditioner in HMS, which became available in version 4.8. And what this tool allows us to do is to alter terrain data by either building walls and or burning streams. So before we get into the nitty-gritty details, let's go ahead and take a look at what a reconditioned terrain file might actually look like after using this tool. The terrain reconditioner consists of two steps. The first step is a build wall step, and the second step is a burn stream step. The picture on the left represents an unaltered terrain dataset that has been overlaid with two shapefile datasets. In this example, the red shapefile represents HEC-12 zones from the watershed boundary dataset, and it is used to build walls. And then the blue shapefile represents a stream network from the National Hydrography dataset, and it is going to be used to burn streams. Over here on the right is a picture of what a reconditioned terrain might look like after using the Terrain Reconditioner tool in HMS. Notice how for the cells that intersect where the red shapefile was, notice how those have been raised. And then for the cells that intersect the streams layer that was input, notice how those have been lowered compared to the existing data set, or the existing terrain data set. Also notice that the transition here for the burn streams, how it's kind of a smooth transition into the existing grade, whereas for the build walls, it's a very sharp transition. And the reason for this in this example is that for burn streams, a smooth transition and a buffer was specified. And I'll go into those in more detail here in just a few. First, I'd like to take a second to talk about a few scenarios where you might want to build walls and or burn streams in your HMS model. All right, let's talk about a scenario where building walls might come in handy. In this picture, the subbasin delineations shown in red are published hand-drawn subbasin boundaries from the NRCS, and those outlined in black were generated by an automated GIS delineation tool using a 10-meter digital elevation map. Notice how the published boundaries differ in a few of the subbasins from the GIS delineated boundaries. And let's say you are involved in a hydrologic study, and for whatever reason, your subbasins in HMS need to perfectly match the published NRCS data. What you could do in this case is use the Terrain Reconditioner build wall step in HMS, and you could input the published watershed boundary data as a shapefile, and then that would essentially force your HMS delineations to match the published data. What about a scenario where you might want to burn streams in your model? Let's say you want to use the 2D diffusion wave transform method, and you want to model how runoff moves over the terrain and eventually collects at a subbasin outlet. But let's say that you have a coarse, maybe a coarse 10-meter terrain data set that doesn't fully capture the channel bathymetry, and you want to try to account for that. Well, what you could do in this scenario is you could use the Terrain Reconditioner burn stream step, and you could input a shapefile, that represents the stream network, and then you could specify a smooth buffer and gradually lower the cells that fall underneath or near the intersection of that stream network shapefile. And you would essentially be burning in channel definition into your terrain data set. The Terrain Reconditioning tool is part of the GIS workflow in HMS, but it is optional. It can oftentimes be skipped altogether, although as you saw in the last slide, there definitely are scenarios where you will want to use this Terrain Reconditioning tool. The first step of the Terrain Reconditioning wizard is a build walls step, and then the second is a burn stream step. If you only desire to burn streams, then you can leave the build walls input blank and then just skip to the burn streams step. Unless you desire to skip a step, you'll always need to specify a path to a shapefile, as well as a smooth buffer and smooth height, or a sharp height, or both. It's completely up to you as the user. If your goal is to force HMS subbasin delineations to match an existing data set, then all you really need is a sharp raise height. The smooth buffering and the smooth height adjustments, those are more applicable if you wish to burn streams. And we'll take a closer look at the smooth elevation adjustments compared to sharp elevation in the next slide. So this current slide represents a cross-section of a terrain data set near a channel. The black dot represents a stream shapefile going into the screen, and the solid orange line represents the original unaltered elevations at this cross-section. The gridded blue rectangle here underneath represents the cells of the raster data set. Over here on the right is an illustration of what happens with the terrain reconditioner burn stream step. In this case, the user has specified a stream shapefile, a smooth buffer of 2 cells, and a smooth drop of 5 feet. The program lowers the elevation of the cell directly below the streamline, the 5-foot specified distance, and then it gradually lowers the other cells within the buffer so that they gradually transition to existing grade. This slide shows once again a cross-section of a terrain data set near a channel, only this time the picture on the right here represents what happens with the terrain reconditioner burn stream step when only a sharp drop is specified. So the program will lower the elevation of the cell directly beneath the stream shapefile, the 5-foot distance, and that's it. There is no buffering operation that occurs with a sharp drop. If you wish, you can specify a smooth and a sharp elevation adjustment. The program will compute the smooth adjustment first, and then the sharp adjustment will be in addition to the smooth adjustment. So if you have a smooth drop of 5 feet and a sharp drop of 1 foot, then the total drop underneath the streamline would be 6 feet. All right, let's talk briefly about what happens where walls and streams intersect. If both build walls and burn streams files are input into the terrain reconditioner, at places where they intersect, the walls will be breached by the streams layer. And this is important because it ensures that all of the cells within the reconditioned terrain drain properly. If you desire to build walls but do not wish to burn streams, I would highly recommend that you still input a burn streams layer. Just leave all of the other burn streams inputs blank. The reason being is that the next step in the HMS GIS workflow is filling sinks. And if your walls are not breached, then the fill sink step will essentially backfill all of the elevations behind the walls until all the cells drain to the outlet. And this is just going to cause some unnecessarily long GIS computation times, as well as potentially produce some wonky results. So moral of the story, if you build walls, be sure to also at least provide a burn stream shapefile so that your walls are breached. All right, that wraps up this lecture. Hope you guys have fun building and burning. Happy modeling.